Hello.
Hello, we'll be starting soon.
Okay.
About another minute or so.
Oh, yeah. No, that's fine. I just didn't want to be late. I actually thought it was at 2:30.
No, not too
Oh,
early.
2. Yeah, there it is. Sorry. Okay.
Real quick, while I'm still waiting on people, would you mind saying something one more time so I can check my speakers here?
Oh, no, I don't mind at all. Yep, here I am, Marissa Chandler at the Zoom meeting.
Thank you. Thank you very
You're
much.
welcome.
Wait one last minute, see if we get anybody else on here. All right. Going to get started now. Going to make this a little bit bigger. Oh, move this down to the bottom here. All right. Good afternoon. My name is John Salter, and I'll be hosting this MAT 1033 final exam review. If you have any questions, feel free to let me know. Also, this material is one of the many resources we do have down here at the Learning Commons. If you have not visited us, I would absolutely recommend taking a trip through. We have a lot of resources, not just for the math courses that we offer at TCC, but then also for pretty much every class, with the exception of some electives like for most of your core classes, we do offer either tutors or specialists or bookmarks or notes or reviews like this one. So it's definitely worth a stop through and see. That being said, we're going to move right along. I have my speaker turned up, so if there's any questions that you have along the way, feel free to let me know. Because of the nature of my viewing capacities, I can't necessarily check the chat all the time. So if you have a question, just let me know, and I'll try to stop every so often so we can kind of take a break and make sure that I haven't lost anybody, okay? All right, well, let's go on and get started, shall we? All right, we're going to start off with functions and lines. All right, functions. Find f of -2 for the following function, which is f of x equals -2 times x to the third power plus x plus 3. All right, so it's already actually, a lot of the steps here are shown for this PowerPoint. I'm just kind of helping to direct your thinking, your understanding on how we're doing this. But as you can see from here, what we're doing is wherever my x value was, I'm replacing it with the value that was inside my parentheses, which was -2. The -2 replaced the x, so I'm going to do the same thing. So everywhere where there was an x, I replace it with a -2, and this is what I get. To solve it out and show the work a bit, I'm going to not only substitute my value, but then simplify. In this case, I found out that -2 to the third power was -8 times -2 is 16. Plus a negative is just like saying minus, and then plus 3. Combine, watching my signs, right? In which case I get f of -2 is equal to the value of 17. So I substitute my value, and then I essentially order of operations, PEMDAS, right? Question, is this grouping of numbers or is this set a function? Okay, well, if I put it into a chart, it's a little bit easier for me to see the correlation between these things. I do notice something when it gets to my x's. I notice that I have a repeat here. I want to pay attention to the repeats. When I graph it out, this is what it will look like, more or less. Notice that repeat, I have on the x-axis, I have two separate values. This is what we call a vertical line test. Whenever I have my input value giving me two separate outputs, that means that it is not a function. I cannot occupy the same space more than once. So for the domain, list all the x values without repeating any numbers if they are used more than once. So the domain of this non-function here is going to be 2, -3, and 3. For the range, it's just the y values. Please make sure you understand the definitions of domain and range. That's something that will absolutely be present on this exam. Please understand the difference between domain and range. Domain is your x, range is your y. Very, very, very important. All right, write the domain in set builder notation. So domain is all of my x values, which we just said. A lot of times, depending on the function, it's just all real numbers from -infinity to +infinity. There are some exceptions, and fractions have some of those exceptions in there, okay? Only two things limit our domain, a fraction or an even index radical. When it comes to a fraction, we cannot divide by 0. I cannot take something and make it into nothing. So our strategy is to find out where will that denominator equal 0, because again, it exists everywhere else. So I set that equal to 0. It's a two-step equation. I add 1 to both sides and divide by 3, and I get x equals 1/3. So that's the one x value where my domain cannot be. So x does not equal 1/3. It's just a visual of that on the number line. So everywhere between -infinity and +infinity, this works, except for there. So I'd have an open circle. So over here is what it would look like. X can exist everywhere except for where X is not, where X is equal to 1/3. All right, is this a function? Well, to determine if it's a function, I have to do my vertical line test. Vertical line test is just like we did a couple slides ago. I cannot have more than one value for each X. No matter where I put a line on this, I'm going to hit more than one dot. So that's a function. All right, evaluate a function from a graph. Okay, well, in order to find a function, not even, it says use the graph to evaluate f of -2. Okay, so what is the function when my x has a value of -2? I go to -2 and draw a line straight down. Wherever that dot is, must be my answer. So I have to follow it over to the y-axis and see where that's at. It looks like -3 from this point of view. There you go, -3. Graphs are supposed to make life easy, not complex. On the slope. Slope is my rate of change, my constant rate of change. Able the points to keep track of what you're substituting. Very, very important. Very, very important. Doesn't matter which one is which, as long as you label them early in the game. So there's going to be 0.1, so x1 at y1. This other one's going to be 0.2, so x2, y2. This is my equation of a slope. This is my equation of a slope. Difference in y over the difference in x. And order is important. So I plug my numbers in. Notice how these two numbers come from this, whereas these two numbers, I don't know why that's happening, come from here. Okay. So that's, let's see. Cool. All right. So when I do it, I have 3 minus 3 on top, -2 minus 6 on the bottom. When I simplify that, I get 0 over -8, which equals 0. Anything with 0 numerator is just 0. So there's a 0 slope. This is going to be a horizontal line. Why is that? Because 0 is neither positive or negative. With slope, positive means increasing, negative means decreasing. This isn't doing either one. It's staying at a straight line, going straight across. Find the slope of this. Okay. If we had this in slope intercept form, we could easily identify this because it would just essentially be my m value or the coefficient of x. I can't just use this coefficient because it's not in the right formula, and that number is bound to change when I do my manipulations. So first I'm going to start with what they gave me, try to get it into y equals blah, blah, blah. So isolate the y term. All right, well, I move the x's from that side. Step 1. End up with 3y equals -5x plus 15. I need to get rid of the 3 now. So I divide everything by 3. Not just one part of it, I divide everything. And when I simplify, that 3 cancels. My y gets by itself, and I just got to simplify that right-hand side. So I get -5/3 x equals, or plus 5. This is why I had to do my manipulations first. If I would have just put down 5, I'd have been really, really off. Didn't account for that negative or the divide by 3. So actual slope is going to be -5/3. Please make sure you solve for y before you try to find the slope. Okay, very important. Very, very important. Next. Sketch the graph of f of x equals -2x plus 1. Okay, again, going back to that y equals mx plus b idea, I need to separate my slope from my intercept here. Okay, so with this method, actually, they want me to pick 3 values for x. We'll plug them in and see what the y equals. So I did it in chart format. And substitute the x values that I pick into the equation. so I can see what the y value or the f of x would equal. So in this case, we plug in 0, a 1, and a 2. Nice, small, easy numbers. I like it. My y values are 1, -1, and -3 when I do the calculations. So I plug all those in, and now I have coordinate points. See this? Boom. Now I have points that I can plot on my graph. This is one way of being able to sketch a graph. Get the points one at a time. And that is literally just connect the dots. Second, and this is kind of my preferred method, is slope and y-intercept. Identify both of those in the equation. In this case, my slope is -2, or in fraction form, -2/1. Because usually slope is a good fraction, because I need to know the rise and the run, right? Which way am I going up and down, which way left and right. And then my b is just 1. So I'm gonna graph that b first. Graph. I'm gonna use the slope to walk to the next point, rise over run. So I'm gonna do the rise and run after this. So first I put the point, b equals 1, it's a little off center, but you get it. Then I'm going to go over 1 unit and down 2 units. It's point wherever I land. After that, connect the dots. And if you notice, it should be the same line, right? Exact same line. All righty. Write the slope-intercept form of the equation for the line passing through the points -1, 4 and 2, -10. So in this one, they actually gave us a little help. They gave us the slope of a line, how to find the slope. And then I have a choice whether I want to put it into slope-intercept form or point slope. It's really either or. I think for this one, because they didn't directly give me a y-intercept, I probably use point slope form. But in actuality, you can use either one of these, and the math is pretty similar. All right, since every line needs a slope and a y-intercept, start by asking if you knew either of these from the information given. All right, looking at the points, x1, y1, x2, y2, I can find the slope by plugging it in. Make sure you plug them in the right order. So the y2 and x2 come first. This is the y2, this is the x2. Then the x1, y1, those come second. All right. After that, I got to do my math. Do a little subtraction, and I get -14/3. Substitute one of the original points in the slope you just found. Again, point slope form is kind of the best because they gave you a couple of points to pick from, and you just found the slope. So that's the one I would go for. This is my slope right here out in front. And then the point I used looks like it was 2, -10, which was my second point, 2, -10. Notice though, even though it was a +2 here, because it has to be x minus x1, it becomes -2 here. Make sure to keep the signs. Distribute and simplify. That slope gets distributed over both items. I end up here. Now I have one x term and a whole bunch of constant terms, so I want to simplify and bring all that together next. So I simplify my fraction first, and then I want to go on and do that -10 work. And when I do, I get a -2/3. So it should be y equals -14/3x -2/3. -2/3. All right. Oh, there it is right there. Nice and pretty. Move on. The equation of a horizontal line, that's a very important key word right there, horizontal line passing through this point. All right, we talked about it a little bit earlier in the previous question. Horizontal line is one where the slope is 0, I have 0 slope. So I'm really just looking for my intercept, where's it crossing the y-axis. So if I plot the point they gave, I know that there is a 0 slope and it's horizontal, so whatever horizontal line goes through that point, which when you think about it and break it down, it's just the same as whatever the y value was, because it's going to have that same y value continually. Horizontal lines are always y equals, vertical lines are always x equals. Just something to put in your back pocket for later. Horizontal lines are always y equals. All right, write an equation going through this point, and it has no slope. Please note, a no slope is very different than a zero slope. Zero is a number. No is not a number. So zero slope, it's not increasing, it's not decreasing, it's a horizontal line. No slope, check that out. No slope is interpreted as undefined. It's a vertical line. You know what? I got a little time on this. I'm gonna show you something I used to show people a long time ago. It's Mr. Slope Face. Sounds silly, but it kind of helps to hammer home this idea of slope and positive, negative. What is it? I know that a positive slope looks like this, increases. Negative slope, something that decreases. And then you have horizontal lines and vertical lines. Horizontal lines have a zero slope. I don't know, I keep doing that. Vertical lines have an undefined slope. And this, more or less, yeah, is Mr. Slopeface. Undefined as a vertical line. All right. Slopeface. To help kind of keep some of these things, our lines just keep disappearing. Positive slope, negative slope, horizontal slope, and an undefined vertical slope. Don't know if it helps. I'm showing you anyway. So this one here, no slope, vertical, going straight through. And again, that's always going to be x equals something. In this case, it's going to be x equals 3. Find the slope-intercept form of the perpendicular, that's going to be my keyword, line, to y equals negative 1/2 x plus 1 going through the point 0, 7. So they gave me a point and they gave me a slope already, but I need to change it for this perpendicular thing. Perpendiculars have a slope relationship that is a negative reciprocal. Both of those are important. So negative 1/2. If I flip the sign, becomes positive, and if I flip the fraction, becomes 2, positive 2. Now that I have my slope, when they gave me this 0.07, they're basically just giving me my y-intercept, which is nice of them. So I could put it in the y equals mx plus b form because now I have a slope of m, which is 2, and my special point, that y-intercept, they gave it to me. Quick and easy. If they gave us a different point, I'd have to plug it in as my x and y and then solve for b, but that wasn't my issue this time. All right, sales of SUV increased between 91 and 99. Growth was roughly linear. Suppose f of x equals this formula, and that models the sales in thousands, and x represents the year. So f of x is sales in thousands, and x is the year. Find the number of SUVs sold in 1994. 1994. All right, cool. Let's get it set up. So I'm looking for f of 1994. Remember, x is my year. And they already gave me the equation. So I plug it in for year. I'm going to have to do a little mathematics. So when I do the multiplication and the subtraction, I get here, which is 6.865. Is how many thousand SUVs? Probably 6,865. But if I want it in like a good estimate, I can round that up and get 7,000 SUVs. Inequality. So we've been using a lot of equal sign. What happens when I don't have an equal sign? I want to graph the solution. X is greater than or equal to 2. and y is less than the x plus 1. Please make sure you know the difference between greater than and less than. Please make sure you understand that. It's very, very key. All right. X is greater than or equal to 2. This is a vertical line passing through x equals 2 to the greater than part in a second. But the x equals 2 part looks like this. But it's not just x equals 2, it's x is greater than or equal to 2. So is it solid or dotted? Since it's equal, of course, it's going to be solid. But they said just go on and check and try. So I'm going to try something that is x equal. No. Trying 3, 2. Is 3 bigger than 2? Yes, so I'm going to include. Oh, okay. So I plugged it in. I plugged the point in for x to see if this was valid. And that's what I got here. Getting everything to the right. For the next one, y is less than 3x plus 1. My y-intercept of 1, my slope of 3, which is the same as 3 over 1. So I'm going to put my intercept first. The slope tells me go here. Is it solid or dotted? Well, this is just a less than, not less than or equal to, so it's going to be dotted. Pick a test point to see which way do I shade. So they pick 0, 0, which is here. It's underneath or less than my graph. So if I plug that in, 0 less than 3 times 0 plus 1, well, I will get 0 less than 1, which is true. So I'm going to shade to include that point. So down there. Where's the solution of both of these at once? It's where I'm shaded in both places at once. So right in there. All right. Graph y is greater than 4x. Y is greater than 4x. All right, so looking at my graphs, all of them show the same line. It goes through the origin, it goes up to the right. I have some differences though. Am I shading to the left or to the right? And is my graph going to be solid or dotted? Well, looking at my inequality sign, I can tell you, okay, so they said graph the line, which again, all the lines look the same. Is it dotted or solid? Looking at my inequality sign, because it's just a greater than symbol, it's going to be dotted. Now, am I shading to the left or to the right? It says my y is greater than the graph. Greater than either means above or to the right. In this case, we're going to be looking at above. Is it above or below the line? Well, it says y is greater, so I need to be above the line. So when I look at these, I'm looking for something that is dotted and shaded to where it's greater than or to the left of the line. Dotted to the left. So these are my dotteds. These are the ones that are to the left. The only one that's both is here. Saying the same thing. Here. It did a red star too. Okay. Solve and express the answer in interval form. This is a tough concept. Please pay attention. Please pay attention. All right. So I look at just the left thing that they gave me, the left inequality. 3 times x plus 1 is less than or equal to 12. Distribute that 3, and I get 3x plus 3, still less than or equal to 12. I want to solve, so I subtract 3 on both sides, and I get 9 on the right. Divide by the coefficient, and I get 3. X is less than or equal to 3. So there's 3. There's my dot, and it's filled in because it's or equal to. It's going, x is less than that. It's going to the left, where all the values less than 3 are. All right, looking at the other side, -2 times x plus 1 is greater than -12. All right, distribute again. I get -2x minus 2 greater than 12. The Add 2 to both sides, I get negative 2x is greater than 14. I have to divide again, but this time I got to divide by a negative. When I divide by a negative or multiply by a negative, I have to switch the direction of my sign. Please don't forget. I'm going to use blue to represent this thing here. So at negative 7, it's a greater than symbol, so it's not going to be filled in. It's going to be an open circle. And I'm going to look for everything where x is less than that. So I'm shading over here. Since this is our and, our solution comes from where they overlap, where are both of these things true at the same time. So basically from negative infinity, which is out here, all the way to right here at negative 7, but it doesn't include it. So it's going to be a parentheses, and infinity is always a parenthesis. So negative infinity, comma, negative 7. All right, express the answer in interval form. This time they gave us just one compound inequality. It has 3 parts and I want to keep it balanced. If I do something in one, I have to do it to the other 3. So it's just like what I do to one side, I do to the other. It's just more others. All right, so got this 11, I got 13, and I got the 3x plus 5. I want to do things to all 3 parts. All right, so we're going to rewrite it again, it looks like. So cover up one area, make it look familiar. All right, so if I covered this up and I looked at just the right-hand side, I can use this to solve for x. Uh-oh, that wasn't it. Cool. In which case, again, same thing I would do normally. It's just instead of doing it to 1 or 2 sides, I'm gonna do it to all 3. So I want to get x by itself. That's the important piece. In order to do that, I need to add 5. I need to get rid of that 3. So I add 5 to all sides. I get 6 is less than 3x, which is less than or equal to 8. X, I need to divide by that 3 to get it off of the x. And I got to do it everywhere. In which case I get 2 is less than x is less than or equal to 8 over 3. So it's basically the same as solving for x. I'm just doing it to all sides of the equation, not just both sides of the equation. But my interval is, my x is valid between 2 and 8/3. As it was a greater than or equal or less than or equal to sign, then this is a bracket. Because this is just a regular less than sign, there's a parentheses. This is how I do it. Exponents. Negative exponents, tons of fun. The negative just means to switch the layers of the fraction. Reciprocate. So 7/6 becomes 6/7. Still squared though, that doesn't do anything to the 2. So now I'm going to go on and just basically distribute that 2. So I get 6 squared over 7 squared. When I do the math on that, 36 over 49. All right. Rational exponents. So this time they're all positive, but this time they're all fractions. What does that mean for me to do? All right. When the bases are the same, I want to keep the base and add the exponents. So my base was a, so it stays a, and I'm going to add the 3/4 and the 5/4. When I do that, I get, what, 8/4? Yeah, I can simplify that. That's just 8 to the second. And this is why we like to do the combining of them, because sometimes it can look a lot easier simplified than it did originally. Okay. Right, moving on. Dividing the answer in scientific notation. Oh, tons of fun. So we get to use some exponents. We get to use some division rules that we picked up along the way here. All right, so I'm going to regroup this a little bit. This is multiplication, so I can kind of split this up, right? We have some property rules about that. So I have just the first component, the 6.2 and the 2 in one parentheses, and then I got the 10s over in their own parentheses. I can simplify exponents on like terms. And I'm gonna keep the base. And this time, instead of adding the exponents, I'm subtracting because they're being used with division. So I'm gonna subtract the exponents, top minus the bottom, basically. And that gives me 10 to the 12th. And the 6.2 over 2, that just divided everything in half to get 3.1. So now I have 3.1 times 10 to the negative 12. So break it up and then recombine it. All right, 16 to the 3/2. It looks ugly, but it's actually something we can work on and break up a bit to where it's something we can solve. So I'm gonna rewrite this as radical, right? It's already a simplified exponent, and that's not helping me. So I'm gonna put it in radical form. When I do, the 2 goes into the index, which generally speaking, when it's a 2, we kind of make it invisible because we just assume square roots, the most common. But whatever that index is goes there. And then the top part of the fractional exponent becomes my just the exponent part. So square root of 16, I could do that. And then I'll do the power last. So square root of 16 is 4. And then to the third power gives me 64. All right. Got a couple different things going on here. I'm just grouping some things using some exponent rules. Let me see what this is. All right. So I see I got some stuff inside of my parentheses, but then all that's being raised to exponent. So I'm gonna break it up 3 terms. So I have the 4, the y to the second, and the z to the negative third. I'm gonna raise all those to the 2. So essentially distributing that outside exponent. All right. All right. And I'm gonna do each one independently. 4 to the second, of course, is 16. And then when I do a power to a power or exponent to an exponent, I just multiply them. So 2 times 2 is 4, negative 3 times 2 is negative 6. But I have a negative still. Remember, negative flips it from either being on the top of a fraction to the bottom or from the bottom to the top. Here, I'm just gonna flip it down to the bottom. Cool. Factoring. Instead of putting things together, I'm breaking them apart. All right. 2 times x to the third minus 18x. So numbers and letters here. I want to factor out my greatest common factor. What's the biggest thing I have in common here? For the numbers, it's the 2. They can both be divisible by 2, but then I also have x in common on both. So I pull that out. I'm left with x squared minus 9. I can go a little bit further if I look inside of that parentheses, though. This is a square minus a square, or a difference of squares. I could break that into x plus 3x minus 3. This is my fully factored. Which of the following is a factor of this? So you want me to factor it up and see which one of these applies? All right, so I rewrite it. This could be factored into a binomial, 2x minus 3, x plus 3. Let me see, do we show how the factoring took place? No. All right, so what I would have done was an AC method, where I would have done this times this, that 8 of 18. And then the last number I had up here was a 3. What number do I have that can multiply to give me this and add to give me this? Is what I would have started with. I'm gonna say 1 positive, 1 negative. 6 times 3 is 18. So make the biggest number positive. So 6 times 3. In which case you. All right, so this is a little method that I use with my students when I was in middle school. I don't know if this helps, but check me out. The first thing was 2x squared. Last term was negative 9. I also just came up with these 2 numbers. The 6x minus 3x is the same middle part anyway. And then what I do is I just factor. What can I factor out of these 2? 3. What can I factor out of these 2? It's the x. What can I factor out of these two? Factor out of 2x. What can I factor out of these two? -3. And so my parentheses are these up here. 2x minus 3, boom, x plus 3. Boom. And that's how I used to show people how to factor. I'm not trying to confuse anybody that's close to the test, but if I look at it, which of these two factors is present over here? Part B. All right, simplify. 5x minus 2 over 4 minus 25x squared. Factoring will help. I can't do it on the top, but I could do it on the bottom. That's a difference of squares again. Oh, good afternoon. Hello. All right.
I thought it was a class and I heard your voice.
Oh, yes. No, man. This is a final exam review for MAT 1033.
Oh, I just did mine upstairs for 18. Always the A students.
Yeah.
I'm getting ready to go now.
Okay. Well, have a wonderful Sunday.
You too.
Thank you very much. No problem. All right. I'm getting back at it. See, I'm gonna factor this denominator because I can't factor the numerator. I want to factor the denominator, see if there's something that maybe can help me simplify. So when I factor it, again, difference of squares, I get 2 minus 5x, 2 plus 5x. And I notice that this looks similar to what I have on top, but not exact. So if I took out a -1, that would actually fix the signs that I have. So I pulled a -1 out of here up top, which switched everything around. So the -2 became positive, and the positive 5x became negative. Now it looks identical. Now I can do some factoring. And when I do that, my common factors are that 2 minus 5x. And when I get rid of them, I'm left with a -1 on top and 2 plus 5x at the bottom. And so that's my answer. Factor the bottom, see if there's anything in common on top, and go from there. Divide. Well, I have a lot of variables here, but it doesn't change my methodology. This is a fraction that I'm dividing, so same, change, flip, keep, change, flip, however you remember it. Keep, change, flip is how it's written here. But the first one stays the same. I change divide to multiply, and I flip the second fraction. I want to factor before I go any further, because there's a lot of stuff going on, and I'd rather factor and see if I could simplify before anything else happens, because otherwise I'll end up with a huge answer. Factoring helps me not have a huge answer. So I factor the top, factor the bottom, factor the top. The bottoms couldn't really be factored. They were pretty prime. Anything that's the same on the top and the bottom, I can get rid of. X plus 1 and x plus 1. Because this is multiplication, I can cancel top and bottom from both sides. If this is add or subtract, I couldn't do that. X minus 2 cancels as well. What am I left with? 2 and the x plus 1, or 2 times x plus 1, or 2x plus 2. Simplify this complex fraction. Again, keep, change, flip is just written in a different order. Remember that my fraction bar, this thing here, just means divide. Again, keep, change, flip. The top stays the same. I change that fraction bar to a multiplication symbol, and I'm gonna flip that second fraction up. Boom, just like that. I have another ultra big thing going on here. I want to simplify. Boom, factored it up. It was a difference of squares. And now I see I have an x minus 4 on top and bottom. So guess what I'm gonna do with those? I'm gonna cancel them. Boom, just like that. What's left? We'll have an x on top, an x plus 4 on the bottom. That's my answer. You cannot cancel this x with this x. This addition keeps them together. It's kind of like marriage, right? Yeah, there's another single person over here, but you know what? We're together. We can't break that up. Addition does that. Multiplication, I can cross simplify and cut stuff up. With addition, nah, it stays how it is. Find the least common denominator. Least common denominator. I'm gonna have to factor this before I can find out what that is. I need to know what the factors are before I can find the least common. All right. So I have 2x minus 2. I'm gonna factor that up to become 2 times x minus 1. I have x squared minus 1. That's the difference of squares. That's x plus 1, x minus 1. Do they have anything in common? Yeah, they do. It's that x minus 1. They both have that. So I'll write that down one time. And then what else do they have in addition to that? Well, there's also a 2 and an x minus 1. So I just want to write it all out. The number by itself comes first, and then the other components. So that's my least common. Subtract. Oh, Lord, heavenly mercy. This is a lot going on right here. Actually, it looks like I just wrote the same thing twice. Like a line in between here. It's the same thing twice. All right. I want to factor the bottoms. This is absolutely factorable. It's a difference of squares. It becomes x minus 3x plus 3. They both have x plus 3 in common. So to make that, I'm going to go on and make it just x minus 3. So now they're both the same. So multiply by my x minus 3 on top and bottom. So now I have 5x minus that 4 times the x minus 3. Some distributive will come next so I can get that top looking a little prettier. So yeah, that's distributive. I get this. I got some like terms going on now. I can simplify that up to x plus 12 over, I could say over x squared minus 9 if I wanted to kind of recombine it a little bit as well. Solve. Well, I got my x's, but I need to get it to where it's just 1x equals something. So what do? The constraint in this problem will be found by x plus 1 equals 0 or x equals negative 1. This is the only value we cannot use, right? I can never have it to where my fraction denominator equals 0. All right. So multiply both sides by the denominator, get rid of that fraction. When I do it on the left-hand side, those things cancel. On the right-hand side, I have something I can use some distributive on. So I get x equals 2x plus 1, or x equals 2x plus 2. Subtract by 2x on both sides, I get negative x equals 2. If I divide both sides by negative 1, I see that x is equal to negative 2. All righty. Solve a quadratic using the AC method. Oh, I was talking about this earlier. I love the AC method. Decide if you want to factor or use a quadratic, you'll get the same answer. Quadratic works for everything. Factoring works for a lot of things, but not everything. All right. So which one are we doing first here? Oh, AC method. So I multiply A and C. So in this case, my 2 and my negative 3, I get negative 6. What are all the factors of negative 6? Okay, here they are. Now, which of these can I combine to get my B value, which is positive 5? Well, the only one that works for that is negative 1 and 6. So I'm split the middle part of the middle term apart using the negative 1 and 6 for coefficients. So 5x becomes, negative 1x and plus 6x, because again, that'll add to give me the 5x. Now I can do factor by grouping. So I look at the first two, I can factor out an x there. And the second two, I can factor out that 3. Boom, did that. Notice how now I have common factors going on of 2x minus 1. Bring that out in front. And put whatever I had as the second. Set everything equal to 0. Solve for my x value. So either 2x minus 1 equals 0 or x plus 3 equals 0. And if I was to solve that out, I get either x equals 1/2 or x equals negative 3. Those would be my two answers. Solve for A. Okay, so this time I have nothing, well, not even nothing, but I have a lot of different variables going on. So I got to get all my A's together. Gather them all on one side. I got MA, and if I move the 4A to the left, I get MA plus 4A. Now I'm going to pull that A out of there. That's the thing I'm looking for. I'm going to divide all the rest of that away. Now I have Z equal, or A equals Z over M plus 4. So bring them all to one side, pull the A part or the ideal variable out, and then divide the rest of that off. Cut and dry, quick and easy. Ooh, systems. All right, how many solutions do you see? Well, a solution is just where my two things cross. So it's right there in the middle. Since these lines have one point in common, where they cross, I only have one solution. Ooh. Solve this system. They gave me y equals 3x and x plus y equals 4. I could use graphing, substitution, elimination, whichever one works best. Since y has been isolated, I'm going to use substitution. Great idea. So since I already had y equals 3x, I'm going to look at the other equation, and wherever there was y, I'm going to substitute it for this value. So x plus the y value equals 4. The y value is equal to 3x. So when I combine like terms, I get 4x equals 4. So x must equal 1. Now that I know that x equals 1, just plug it back in. If y equals 3 of those x's, then 3 times 1 is 3. Y equals 3. So x is 1, my y is 3. Final answer, 1, 3. Solve this system. Again, two equations. 2x plus y equals 4 and 5x minus y equals -1. All right. Okay, how did we jump over here? What did I do? Okay, so it looks like I multiplied my first equation by 3 on both sides to where I got 6x plus 3y equals 12. And I compare that with my second equation. The reason why I did that is because now my y's are the same and different. I have equal opposites. It's a good elimination problem. I'm going to combine these to eliminate. I'm left with just x's and numbers. And I can solve for that, getting x equals 1. And now that I know what one variable is, I can plug it into either equation and solve for the other. So I plug it into that first equation again. So 2 1s plus y equals 4. So 2 plus y is 4. If I subtract that 2, I get y equals 2. I got an x value 1, y value 2. My answer is 1, 2. I guess the big jump was knowing that I had to multiply by 3. And again, I had minus something plus that same variable. The only difference was the coefficient of 3. So I just multiplied by 3. But since in order to make this even, I had to multiply everything by that 3. Here and here. So we didn't explain that in this slide. I just want to make sure we got it. All right. Quadratics. Use a quadratic formula. Okay, cool. What's quadratic formula? X equal to negative b plus or minus the square root of b squared minus 4ac. All over 2a, of course. All right, so only real question is what's a, b, and c? A, B, and C are the coefficients. So in this case, A is 3, B is -2, C is 1. Now that I know my variables and I know my equation, combine those two things in, and it'll look like this. That's pretty funky looking, but with a little mathematics, I can make it less fun. All right, let's see where we at. Simplify. Multiplications first. So this becomes positive. This becomes 4. This combines all up to be a 12, but the negative is still there. This is a 6. Now from there, look inside that radical, make that a little prettier, combine some like terms, I get a -8. All right. I substitution. Remember, whenever I have a negative, I can kind of pull it out of that radical by making it equal to I. And the square root of 8 breaks down into 2 square root of 2. And they show the manipulations on the right. So I get 2 plus or minus 2i square root of 2 over 6. Factor out a 2 because I have one here and kind of embedded in here. Or if you want, you can split it up. I usually leave it all as 1, but either or. Simplify it, and I get 1/3 plus or minus I square root of 2 over 3. Again, I probably would have left it all as 1 and been 1 plus or minus I square root of 2, all of that over 3. But it's really whatever floats your boat. Multiply. Multiply with fractions, let's multiply straight across. But this is a lot going on. I'm probably going to try to factor this up, especially these denominators, before moving forward. See if I can simplify out that way. Boom. So they did difference of squares on the left, factor out of 3 on the right, and up top I can factor out of 5. Look for any common factors on top and bottom. Do I have any? Absolutely. I got the 2n plus 3 on top and bottom. I also have the n plus 1 on top and bottom. Get rid of all of that, what's left? Okay, well, on the top, I just got a 5. On the bottom, I have an n minus 1 and a 3. If you want, you can distributive property that, but not always necessary. Radicals. Radicals. All right, find g of 5/3 if g of x is equal to the square root of 3x minus 5. All right, so the first thing I'm going to do is I'm going to substitute that value in for x. It'll look like this. Simplify, because I got some multiplication and some subtraction going on in here. Boom. I can simplify, and that multiplication just gives me 5. And when I do that subtraction, I get 0. And square root of 0 is 0. Square root of 12. Oh, okay, I can do that. Well, square root of 12, I can break that up into square root of 4 times square root of 3. Why do I do that? Because square root of 4 is a perfect square. It equals 2. So 2 square root of 3. All right, I want to add these. Same thing. I want to see, can I get any of that? Can I essentially factor these up so I can get something similar going on? What do I got? Well, 50 is 25 times 2. And 18 is 9 times 2. If I split that up a little further, I see that I get square root of 25, square root of 2, square root of 9, square root of 2. Some of those are perfect squares. So when I identify that and I do the math, I get 5 square root of 2 plus 3 square root of 2. Now I have identical radicals. Now I can add and combine. All right. 5 of those things plus 3 of those things gives me 8 of those things. All right, simplify. All right. I want to break it up into its individual pieces. I got 3 terms inside of there. And all of them are looking for cube roots. So if I factor these things up, 54 into prime factorization, I get 3 times 3, which is 9, times 3 times 2, 9 times 6 is 54, okay? Then I got 4 x's and 7 y's, but I want to break this up into groups of 3. All right, so what's that going to look like? I got 3 3's, I got 3 x's, I got 3 y's, so I can cube root that, pull that outside a little bit. So 3 3's, 3 x's, and 2 sets of 3 when it comes to the y's. So I brought out 3, an x, and 2 sets of y, and left everything else inside. 2, this x, this y got left. But this can get simplified a bit too. Evaluate square root of a fraction that consists of perfect squares. So essentially, I'm going to take the radical of the top, radical of the bottom. Perfect squaring, I get 4 over 5. Multiply. Okay, well, this is a distributive property, essentially. I'm going to distribute that square root of 2 over both of my terms on the inside of parentheses. I'll get square root of 2 times square root of 8x minus square root of 2 times square root of 2. That's square root of 4. So square root of 16x minus square root of 4. Square root of 16 is 4. I don't know about square root of x. And then square root of 4 is 2. Solve. Okay, I got an x on both sides, so I need to move to where all my x's are on one side. What am I gonna do for that? Well, I could square it to get rid of the radical, but what I do to one side, I gotta do to the other. All right. Now after that, I also moved everything over to the same side just to see where I'm at. I get a quadratic if I do that. So I could factor it, or I could use the quadratic formula. In this case, I'm just going to factor it, factor it up nice and evenly. Say each of those binomials equal to 0 and solve for x. So what can x equal? X can either equal 7 or -2. And we're going to go back and double check that. 7, plug it in. I get square root of 49. Does that equal 7? Yeah. Plug this in. Is -2 equal to the square root of 4? It says no. I guess because they only wanted the positive square root. All right, so x equals 7 is my only good answer. Cool. Simplify by rationalizing the denominator. By rationalizing, it means I don't want no radicals down there. I'll multiply by that same radical. Square root of 5 times square root of 5. Gets rid of the radical. It gives me just a plane. Or it gives me square root of 25, which essentially gets rid of the radical. And at top is just 3 square root of 5. So I just multiply top and bottom by whatever the bottom was. Oh. Okay. Thank you, God. Cool. The formula L cubed root of 36W relates to the weight of one species of bird to its wingspan length in feet. Find the wingspan L of a bird that weighs 6 pounds. All right. Well, they told me this equation, and W is the weight, and they said the weight is 6 pounds, so I substitute W for 6. Do a little multiplication, I get cubed root of 216. If I plug that in the calculator, I find, or factor tree. Nice. 36 times, okay. So it looks like it breaks down into 6. The hell is 6? Cool beans. All right, cool beans. Pythagorean and geometry. All right, hypotenuse of a right triangle is 13. One leg is 12. Find the length of the other leg. Okay. Well, I have my equation for finding the relationship between hypotenuse and legs, which is a squared plus b squared equals c squared. A and b are legs, c is the hypotenuse. So they told me hypotenuse was 13. One of the legs is 12. I gotta find the other one. Plug in my numbers. It'll look like this. I know how to do the square. So if I did that, I get 144 plus b squared equals 169. I'm solving for b, so I subtract 144 on both sides, and I get 25. Take the square root to get b by itself, and b is equal to 5. This is actually a pretty common triangle. The 5, 12, 13 is one of them you'll see a lot, along with the 3, 4, 5. All right, find the volume of a cube with sides of length 3 ABC. Here's a cube. Cube has side lengths of length, width, and height. And they told me that for length and for width and for height, they all equal 3ABC. To find volume, I multiply length, width, and height. So if I substitute my values in, it'll look like this. And when I do some mathing, I get 3 times 3 times 3. all the A's, all the B's, all the C's. Simplified gives me 27 A cubed, B cubed, C cubed. Why we call it cubed? Because it's the same thing 3 times. Okay. And then that was it. That was the end of the show. We made it. Do you have any questions, comments, or concerns? Hello. Anybody?
No.
Anybody?
No, thank you very much for your time.
Absolutely, absolutely. That's what we do here in the Learning Commons. If there's anything that I can do to help, aid, or assist, please let us know.
Okay, terrific. Thank you very much. Have a great evening, Mr. Salter.
You as well. Enjoy your weekend.
You
And
too.
if there's anything I can do, let me know. Talk to
Okay.
you later.
Okay, bye.
All right, bye. All right. I don't know how to undo this. Here we go.